Good day to you all. My name remains Matthew Ocheleka Itodo, lecturer with Federal University of Health Sciences, Otukpo, Department of Biochemistry. This is Biochemistry of Homeostasis, and I will be concentrating on this area, which will be our topic of discussion, is acid-base balance. Acid-base balance. I want you to listen attentively. We proceed. At the course of this class, I want you to take notice. This is the objective that we are going to achieve at the end of the class. You should be able to differentiate between acid and a base with relevant example. You should be able to differentiate between acid and base with relevant example. 2. You should be able to know the difference between weak acid and strong acid based on the extent of dissociation. You should be able to know the difference between weak acid and strong acid based on the extent of dissociation. And then the final one is that we should be able to know the example of what? Acid dissociation. Should be able to know the example of acid dissociation. Listen attentively as we proceed. Now, just as a point of introduction, hydrogen ions represented with what? H+ are present in all body compartments. There is no any part of the body compartment that you will not see hydrogen ions. And so that brings about the need for maintenance of appropriate concentration of these hydrogen ions. Okay, for normal cellular functions. Okay, and so I also want you to understand that what hydrogen ion concentration is also the same as what acid-base balance. I think you all know that what hydrogen ions concentrations, we can define it as what pH, which is what negative logarithm of hydrogen ion concentrations. That's the definition of our pH. So it can also be referred to as acid-base balance. So if you can maintain your pH of the body, you are also maintaining acid-base balance. So acid-base balance or pH of the body fluid is maintained by a closely related mechanisms. So means we are all trying our best to make sure that the pH of the body is normal of that normal physiological pH of 7.4, okay, to maintain it at that neutral point. And this process involves three main important systems which in the body, which involve the buffer systems, the respiratory systems, and the kidney. These are the three major areas that do the work of maintaining the acid-base balance to keep the body in normal health. So as we proceed, then we are talking about acid-base balance. Then what is an acid and what is a base? Listen carefully. Now we can say that acid are substances that are capable of donating protons. So any substance that can donate protons is an acid. And while base are those that can accept protons. Any substance that can accept protons, we refer to it as what? As base. Remember our objectives, that what we want to achieve was to differentiate between an acid and a base with relevant example. So this is the example of what? Of an acid. Now look at it. This HA is a symbol. We are using this HA to represent a weak acid, for example. If this weak acid dissociate, it would what? Release protons. It would donate protons. And we say acid is for a substance that donate protons, and also it will donate this proton and form a conjugate base. And hydrochloric acid is a strong acid. If it dissociate, it will what? Donate this proton and form what? Chloride ion as a conjugate base. Then look at carbonic acid, okay, as a weak acid. If this carbonic acid dissociate, it will donate this proton and release this and form hydrogen carbonate as a conjugate base. So in all this, you see that they are what? Donating H plus, H plus, H plus. Okay. Now look at it here. There is H attached to this carbonate here. Listen carefully. I'll tell you the meaning why there is H attached to it before we finish these topics. Now base. Now this is our ammonia, it's a base, and this is our hydrogen carbonate, which is also a base. From here we call it a conjugate base, so it means here is a base. If this ammonia as a base accept proton, you know we say a base is something that accept proton. Look at it. It accept this proton, now it form what? Ammonia. Okay. If this hydrogen carbonate accept this proton, become what? Carbonic acid. So now can you now see now? Okay, so we have achieved the first objectives. Now the second objective now is that what? We should be able to differentiate between weak acid and strong acid based on what? The extent of their dissociations. How can we say this is a weak acid and this is strong acid? Now we look at what the way they dissociate, okay, to know whether they are strong acid or weak acid. So strong acid dissociate completely in solution, okay. When an acid dissociate completely in a solution, we call it what? Strong acid. But why the weak acid, they dissociate incompletely or partially, okay, incompletely, we call it what? Weak acid. Okay, let me go and give you relevant example that will help us. Examples of acid dissociations. Okay, this hydrochloric acid. Now let's see whether it is a strong acid or a weak base. This hydrochloric acid dissociate and donate this proton and form this hydrochloride ion as a conjugate base. But look at this hydrochloric ion, there is no H attached to this side. Okay, means the dissociation is what? Completely, it is 100% dissociation, so we call it what? A strong acid. But now look at this acid now, carbonic acid. Now look at what happened. When you donate this proton, okay, you still have hydrogen attaching to this carbonate here. To show that what? It is a partial dissociation, means only the 50% it is what? Dissociated here. So we said that in the solution of hydrochloric acid, almost all the molecules dissociate and exist as what? Hydrogen ions and chloride ions. Okay, can you now see now? Hence, the concentration of the hydrogen ions is very high and it's a strong acid. But in the case of weak acid, which is acetic acid, which I give you example here, it will ionize only partially. And so the number of the acid molecule existing in the ionized state is much less. So it may be what? 50%. So in this place, it is only 50% that is what? Dissociated. That is what we are talking about. So we have finished